We're going to do an overview of systems of equations. Now, this is not for somebody who's never seen this before. This is for people who have already done this lesson but need a review. When you have a system of linear equations, it's where you have two or more linear equations that have two or more variables. The solution is where that point, that ordered pair, works in each equation. So if it is a solution, it will work in both of those equations. Remember that we learned three different ways to find those solutions. 1, graphing, 2, substitution, and 3, elimination. And we're going to go through those quickly. In order to solve by graphing, we have to put the graphs on the same graph. All of the solutions to this equation right here are represented on this blue line. Now, just really quickly, remember we begin at -1. So we're going to put a dot right here, and our slope is 2, so that's rise 2, run 1. Rise 2, run 1. So up 2, right 1, up 2, right 1, and then draw the blue line, and that's all of the points that will work in this equation. For the red one, we're going to start at 5, and then our slope is -1, which is down 1, right 1, down 1, right 1, and the red line represents all of the points that are solutions here. You will notice that there is one point right here that is on both of those lines. That is the solution to the system, and that's how easy it is to do by graphing. Substitution is a little bit different, and we have some steps here. Now, these are steps that are written out, and these are my abbreviations. The first thing you want to do is solve for one variable. I say isolate that, okay, in at least one equation. Step 2 is to substitute. Once you've solved for a variable, you want to substitute what it equals into the other equation. And then step 3 is you want to go ahead and solve that equation. At that point, you only have one variable. You'll end up with x equals 3 or y equals 7, whatever it is. You're going to take that, substitute it back into the original equation that you used, and solve that one. So let's do an example for that. All right, and I'm going to say the steps as we do them. Number 1, isolate the variable. Now, make this easy on yourself. I would either isolate the x in the first one or the x in the bottom one. Some people like to isolate the same variable in both of them and then just set the two resulting equations equal to each other. That's totally up to you. I personally, and this one would probably solve for x in the second equation by adding y to both sides, and that's going to give me x is equal to y plus 5. So that's isolate. Step 2, substitute. I'm telling you here that x and y plus 5 are the same thing. So take the y plus 5 and substitute it in place of the x in the other equation. So that's going to give me y plus 5 plus the two y's that are already there is equal to -1. Step 3, solve this equation. So that's going to give me 3y plus 5 is equal to -1. Subtract 5. 3y is equal to -6. Divide by 3. Y is equal to -2. Now I know as y is equal to -2. Step 4, take this, substitute it back into the y. I can either put it in the y here, or I can use this one because these are the exact same equations. This one's just rearranged. So I'm going to put the -2 in here. So I'm going to get x is equal to -2 plus 5. And then the last step is to solve this, and I get x is equal to 3. So the solution to this system is 3, -2. If I were to graph those two lines, they would cross over each other at point 3, -2. The next method is the elimination method. And again, you're going to write the system so they look alike. I say line them up. Line them up. It means the x's are underneath each other, the y's are underneath each other, the equal signs are underneath each other, the constant signs are underneath each other. Then you're going to eliminate one of the variables and solve for the other. Now, that's a little confusing. What you have to do is you have to make sure that you have opposites, because when you add opposites together, they eliminate each other. So you want to make sure you're going to eliminate one of the variables. If you do not have opposites at this point, you have to force opposites to happen. And I'll give you an example of that in just a minute. All right, then you're going to solve it, and you're going to add them together, and you're going to solve for the resulting variable. And then you're going to take that solution and put it back in and solve for the other variable. So let me give you an example. So we want to line them up. These guys are lined up. See how this is all lined up? That's what I want. Take that away. So those are all lined up. Now I want opposites. I don't have opposites right now, but I've got a positive 3y and a positive 3y. So what I'm going to do is I'm going to take one of these equations, it doesn't matter which one, and I'm going to multiply the whole equation by -1. So I'm going to take this bottom equation right here, and I'm going to multiply everything by -1. That's going to make that a positive 2x, a negative 3y, and a positive 5. Now, this equation is not here anymore. I'm going to take the two resulting equations and add them together. 3x plus 2x is 5x. 3y and negative 3y, that is eliminated. The equal sign drops down. 15 plus 5 is 20. Solve this. X is equal to 4. Okay, that's half of your answer. Now I'm going to go back up here to my original equations, and I'm going to pick either one of them. It doesn't make a bit of difference, and I'm going to put a 4 in place of the x. So I'm going to use the top one. I'm going to go 3 times 4 plus 3y is equal to 15. That gives me 12 plus 3y is equal to 15. Subtract 12 from both sides. 3y is equal to 3. Divide both sides by 3. Y is equal to 1. The solution to this system is the ordered pair 4, 1. Again, if I were to graph these two lines on the same coordinate plane, they would cross over at 4, 1. Okay, let's try this next one here. They're already lined up. If they're not, you just have to move things around. I do not have opposites. I have a choice. I can either make opposites of the x's by multiplying everything on the top by 3, or I can make opposites of the y by multiplying everything on the bottom by -2. Sometimes you may have to multiply both of the equations, change both of the equations to make opposites. In this case, I think I'd like to multiply everything on the top by 3, which is going to give me 3x plus 6y is equal to 33. And on the bottom, I've got negative 3x plus y is equal to -5. That's going to give me 7y is equal to 28. And that's divide both sides by 7. Y is equal to 4. Okay, then I'm going to go back to one of these equations. I'll just use the top one here. I'm going to put a 4 in place of the y. So I'm going to x plus 2 times 4 is equal to 11. X plus 8 is equal to 11. Subtract 8 from both sides. X is equal to 3. That means the solution to the system is the point 3, 4. Sometimes there are two special cases that you might encounter. One is parallel lines, which means that they're not going to touch at all. And the other one is where the lines are right on top of each other. You have to be able to recognize those. So let's see how you will do that. Parallel lines, if you're looking at a graph, you're going to see them. You're going to see two lines tilted in the same direction. They do not touch. If you are using substitution or elimination, you're going to be working along, and all of a sudden, the variables are going to disappear. They're gone. And you're going to end up with something like 0 is equal to 7, or -3 is equal to 5. You're going to end up with a statement that is false. And that's basically saying, hey, you can put whatever you want in here for the variables. It's never, ever going to work. So we say, in this case, that there is no solution, or you can use this symbol to represent that there is not an answer. If they are the same line, again, when you go to graph them, you will see that the two lines land right on top of each other, which means how many points are there that work in both of them? A bunch. a bazillion. In fact, an infinite number. So we're going to say this has an infinite number of solutions. If you're using substitution or elimination, once again, the variables are going to disappear, but you're going to end up with something like 0 equals 0 or 7 equals 7. You're going to end up with a statement that is true, which says use any real number that you want because everything you put in here will work. Okay? We're going to finish up here quickly by graphing linear inequalities. And if you remember back on a number line, we had to distinguish if you used a greater than or a less than sign, we had an open circle on the number line and then an arrow going one way. If you use greater than or equal to, less than or equal to on a number line, we used a closed circle with an arrow going one way. Well, it's the same thing here. It's just that if you have the or equal to, you're going to use a solid line. If you have just a greater than or less than, you're going to use a dotted line. If you have a greater than symbol, you're shading above the line. And if you have a less than symbol, you shade below the line. So we're actually shading a segment. So let's give you an example of this. The first thing I would do is put this in slope-intercept form. So I would subtract 5x from both sides. That's going to give me 2y is greater than negative 5x minus 8. I'm going to divide everything by 2, and that's going to give me y is greater than negative 5 halves x minus 4. So we're going to begin our graph at negative 4 on the y-axis. We're going to go up 5, left 2, up 5, left 2, or we could have let the negative go to the 5 and go down 5, right 2, and either way they're going to make a straight line. Since this does not have a solid line here, it will not have a solid line here, so we will put in a dotted line, and that's our boundary. And now we just have to decide which side are we going to shade. Since this is greater than, we're going to shade above the line. If you're not sure where above the line is, look at your y-intercept and say, okay, this is above it. So I'm going to shade right here, and there it would be. We're going to put that together very quickly with a system, and basically what you're going to do is you're going to graph both of these on the same coordinate plane. So y is less than or equal to 3. When you have just the y, you know that that's a horizontal line. That's this one right here in blue. So that's going to be the blue one. Let's grab the blue pen here really quickly. So this one is the blue one right here. There is a solid line here, and it's shaded down below. This one is going to start here at 5, go down one, down one, right one. So this is going to be the red one right here. This is a dotted line, and since it's greater than, we shade above it. And this pinkish purple area right here is where those two overlap. That's where your solutions are. So 6, 3, since it's on the solid line, and 8, 1, since it's in this overlapping part, are solutions. 2, 6 is not, and negative 1, 4 is not. And that's it.